Welcome to the new week, Advanced Algebra students. Let's go ahead and get ready here for our first lesson of the week. This is 14.5, and we are going to be looking at the law of cosines. You know what? I think I grabbed the wrong notes. I didn't want that. Sorry, we are doing 14.4. We are doing the law of sines. Law of cosines is for tomorrow. So let's go ahead and let's look at the law of sines. And the law of sines is basically a formula that allows us to solve not just right triangles. So if you remember before, we talked about how we could, in the last section in 14.3, we talked about how we could find the missing parts of right triangles by simply knowing one side, or if we knew two sides, we could find the angles, or if we knew one side and an angle, we could find any of the other sides and the other angles. So with a law of sines, what we find out is this works for any triangle, doesn't have to be a right one, so long as we know three parts. We need to know an angle, and we need to know we either need to know two angles, or we need to know an angle and two sides. And then we can use the law of sines. So let's go ahead, let's look at what the law of sines is. So first off, we have to talk about a triangle, and I've labeled this. Notice there's no angle that's told to be a right angle. So this ABC is not a right triangle like this. It's simply that the way we do need to keep in mind that this angle A has to be opposite the side that I call A. And so the angle B is opposite the side you call B, and the angle C is opposite the side you call C. Well, in any triangle where you label the sides and angles accordingly, so opposite sides and opposite angles match up with their letter, the following ratios are equal. So the sine of angle A equals side A. The sine of angle A over side A equals the sine of angle B over the side B, and the sine of angle C over the side C. So what happens is if I can take two of these ratios and fill in three of the four parts, then I can solve for the missing part. That's what happens with the law of sines. We also have a formula that comes from the law of sines that the area of a triangle is simply 1/2 two sides B times C multiplied by the sine of A. And this works when we don't necessarily know the height. So if we know two sides and the angle in between, the key here is this angle A is always going to be the angle that's in between these two sides B and C. So if we know two sides and the angle in between, we can find the area. So we're going to use these two formulas to find areas and to find missing parts of triangles. And that's all there is to it. So, and on the test, so you know, we will do stuff with law of sines, but on this test I will, because obviously we're covering 3 chapters, I will let you have notes with you. So you can have your notes with you. I would suggest putting all the essential stuff on one piece of paper. You don't want to try to be thumbing through your notes. You won't have time to do that. But you can easily boil all your formulas down and put them on one paper to help yourself out. So let's look at some examples. So first we're going to look at area. So here we're given a triangle, and we are asked to find the area here. So we just plug into our formula. We know we have two sides, and we know we have the angle in between the sides. So we know it's going to be 1/2 times 8 times 12. Those are our two sides, 8 and 12 here, times the sine of our angle, 25. And of course, this is not a known angle in one of our triangles, so this is a calculator problem. So we punch this into our calculator, and when we punch it into our calculator, we get 20.286 square meters. Okay? And since they gave us units, we need to give units in our answer. If they don't give us units, we don't need to give units in our answer. So it's that simple. It's just straightforward, right in your calculator, to find the area. All right. Now let's look at the more complicated thing. Let's look at solving for parts of triangles. So in this case here, we have two angles and a side. And notice one of the things, really, if we have two angles, we know we really have 3 angles because we can always find this angle by taking 180 and subtracting these 2 angles from 180 to get the missing angle. So really we can do that in any situation. So what we need to do is we need to set up 2 ratios. So we always look for an angle and a side that are opposite each other that we know. So we can set up the ratio here and know that the sine of 67 degrees over 9, so that's the first one we'll set up. We know the sine of 67 degrees over 9 has to be equal to the sine of 35 over the opposite side over x. Now we have, going back, we just have a proportion with 1 part missing, and we just have to solve for the missing part. So this is something you've done back in junior high math. You can think of it cross multiply and then solve for the x. So if I cross multiply, I get x times the sine of 67 is equal to 9 times the 35, sine of 35. Now I will go ahead, solve for the x, so I will divide by what's multiplied by it, divide by the sine of 67. So I get x is equal to 9 times the sine of 35 divided by the sine of 67. Now at this point is where I'll enter it in my calculator. If you are in degree mode, which probably for this section I would suggest you go into degree mode, you can just enter these without the degree symbols. If you aren't in the degree mode and you're in radian mode, then you must enter those degree symbols in when you do that. And doing that, what you end up with, just straightforward calculator operations, you end up with 5.608. I would suggest you practice with your calculator right now, enter that in your calculator, and make sure you come up with that answer. And in this case, we have no units, so we don't have to list any units in our answer. All right, let's look at another example. So now we're going to solve for alpha. We're going to solve for an angle when given this triangle. So once again, we will use law of sines, and in law of sines, we always look for an angle that we know and an opposite side that we know. So here's an angle, 22 degrees, and the side opposite is 4. So we can set up that trig ratio of the sine of 22 degrees over 4. And now we'll look here, and we can set this up, the sine of this unknown angle over 9. So that has to equal the sine of alpha, the unknown angle, over 9. Now we will just go ahead and we will solve for alpha. So we'll do our same thing. We'll cross multiply. And I know 4 times the sine of alpha is equal to the 9 times the sine of 22 degrees. Now I want to get alpha by itself. So the first thing I will do is divide by 4. So I will get that the sine of alpha is equal to 9 times the sine of 22 degrees divided by 4. And if you remember in this situation here, when you want an angle and it's inside of a trig function, you know that angle is equal to the inverse trig function of this answer here. So I know alpha would be equal to the inverse sine of this. So I will set up alpha is equal to the inverse sine of 9 times the sine of 22 degrees over 4. Once again, this is just simply entering in your calculator. Type in inverse sine. Inside inverse sine, you put in this fraction here. Let your calculator do the work. If you are in degrees, you can just go ahead and enter it. You don't need a degree symbol, and it will give you the correct answer. If you are in radians, you must put in the degree symbol, and then at the end you have to put in the arrow DD to tell it to give you an answer in degrees. Otherwise, it will give you an answer in radians. Once again, this section, the easiest thing to do is just put your calculator in degrees. But if you didn't, you'd actually have to enter it like this. But you do that, this is your answer you get. Once again, you should take out your calculators now and you should practice and make sure you actually get that answer to verify that you know how to do it. Okay, that's what you're going to be doing. It's all calculator based. I expect to see your setup on all of these, not just like some magical answer that poofed out of nowhere. You should always write down what you're entering in your calculator, but it should be pretty straightforward. So there is your homework. It is 6 through 15, all of those problems. And if you have questions, go ahead, and send me a quick message. And we do have a Zoom this afternoon if you have questions that you need to ask me over Zoom. Okay, hope things are going well, and we'll see you when it's time for tomorrow's video.